Hey guys, I got a couple emails about how to solve particular questions on the homework, so I thought I'd just do another example of just something different, something a little bit different than the one I did before. And let's just focus in on number 14. Okay, so number 14, they're giving us the 41-degree angle here. I'll just redraw it a little bigger so you can see it. You've got 41 degrees was down here. This is letter C, this is 17, and this is D, number 14, from the homework. Okay? So what happened was, they saw the video and they're like, okay, I kind of get that, but this one's a little different because they're not giving us the hypotenuse. That other example, the hypotenuse is, the hypotenuse was given and we used sine and cosine, no big deal. But for this one, again, you just ask yourself the same question, what do you have and what do you need? If this is the angle we're going to use, well then I have the opposite, that's what I have, and I need the hypotenuse. I also need the adjacent. And it doesn't really matter which one you do first, but let's just focus on one at a time. You need the hypotenuse and you have the opposite. Which trig ratio uses opposite with hypotenuse? Okay, if you don't remember, try to remember chief SOHCAHTOA. If you don't know what I'm talking about, watch the other video first. Here's chief SOHCAHTOA, and we're looking for O for opposite and H for hypotenuse. So let's see, OH, that's this one. So that's my sine. This would have been cosine adjacent hypotenuse, and then tangent would have been opposite adjacent. So this is the one we need for solving for D. So here we go. The sine of 41 degrees equals the opposite divided by the hypotenuse. Alright, sine 41, right from the calculator. Let's see. Put that in there. Sine 41. 0.6561. 0.6561. Straight from your phone or your calculator or Google, whatever you're going to use, equals 17 over D. And then here again, it's a very common mistake right here. A lot of people, even if they do this trick, sometimes they still just think you multiply by whatever the number is. Doesn't work like that all the time. You got to really look at your situation. In this situation, I'm going to be multiplying 0.6561 times D, which I still don't know what that is, but that's okay. I can figure it out. 6561 times D equals 17 times 1, so 17. And if I want to solve for D, I need to divide out whatever this messy number is. If you've got, 3x equals 9, right, and you're trying to solve for x, you divide both sides by 3. It's really the same thing, except it's just a decimal number instead of a whole number. Alright, so that's what we're going to do. 0.6561. 0.6561. That takes care of that. So D is approximately whatever 17 divided by 6561 is. 17 divided by 0.6561 is about 25.9. Alright, so D is about 25.9. And here's where the actual issue was, because in the video we just said, okay, forget about D, let's solve for C now. And we can actually still do that here, but I know the direction said, okay, you need to practice using sine and cosine, so they're making us essentially use this value. Because if I'm going to try to use cosine, hang on a second. Okay, sorry about that, silly cats. If I'm going to try to use cosine, well, cosine 41, I'm going to use adjacent and hypotenuse, but if I just told you to pretend we don't know what that is, then there's no way we can use cosine. So based on the worksheet's instructions, I guess we technically have to use this if we're forced to use cosine. So let's just do that just to make sure you can at least get through the work. Cosine, of course, of 41 is going to be, cosine is adjacent over hypotenuse, right? The cats. Hang on one sec. Alright, sorry guys, I'm having some serious shadow issues here in my office. So I'm just going to try to move things around so you can see it. Let's just get back to solving using cosine. So cosine 41, cosine, of course, is adjacent over hypotenuse. So adjacent is what we need. Hypotenuse is actually what we now have, assuming we didn't make a mistake there, 25.9, and now we can solve. So cosine 41 is, it's probably hard to see with the glare, so I'll just write it down. 0.7547 equals C over 25.9. And again, this so we don't fall into the trap, I'm just going to follow the cross multiplication trick, procedure, whatever you want to call it. And I get C is approximately whatever 25.9 is times 0.7547. Okay, so C is approximately times 25.9. I get, when I put that in the calculator, I get about 19.55. Okay, it's 19.6, whatever you want to call it. If you follow my advice from before when I said, hey, try not to use this number, going forward, then you could just go back and say, all right, how else could I have gotten C using the 41 degrees and the 17? And yeah, I know the direction said you had to use sine and cosine, but let's just pretend this was a problem, on a test where it just specifically said, solve for C and D. No it didn't say you had to use one thing over the other. Well, if that's the case, then I'm looking at 17 as the one I want to use, and that's opposite. So I have the opposite, and I need the adjacent. Well, tangent is what uses opposite with adjacent. So I could actually solve for C using tangent as well. Let's try it. Tangent of 41 degrees equals opposite, 17, over adjacent, which is C. Alright, so now I'm going to use tangent of 41. Tan 41 straight from the calculator. And I don't know if you'll be able to see that with the glare, but it's 0.8693. 0.8693 equals 17 over C. I'm going to cross multiply. Look at this one. Again, I'm going to have to deal with the decimal going with the C this time. So 0.8693C equals 17. Divide both sides. And I get C is approximately, let's see, 17. I can't even see it. 17 divided by 0.8693. Let's see if we can get that in there. 19.555. So 19.56, which is very good news because that's exactly what we got. Or not quite exactly, I guess, right? Depends on how you round it. 19.55, 19.56. Again, it all depends on how you round your stuff when you do your, tan 41, cosine 41, whatever. Perfectly acceptable. There's even another way you could have done it. We basically just used sine, cosine, and tangent all in the same problem, but technically there's another way we could have done it. And I think I talked about this in the other one too. If you trust that you got D correct, and you've got the 17 already, you've got 2 out of 3 sides of a right triangle. You could have used the Pythagorean theorem technically if you really just were desperate and you had to solve for C. Again, I know the directions said you had to solve for using sine and cosine, but I'm just saying if you're in a bind, you could have done that. All right, so hopefully that helped. And obviously, if you have any more questions, let me know. Sorry about the sun situation, the way it's coming in the room, but later on, obviously, it'll be a little easier. Okay? All right, talk to you later. Bye.